Hey everyone, welcome back to part 2 of chapter 5. And in the first video, of course, we reviewed some of those concepts about variable cost, fixed cost, and mixed cost, which have components of each. And now, of course, we're going to put those to use to actually have some business applications and show you how we might do that. So the scatter graph method is, of course, a quick and dirty estimate, as the chapter explains. This isn't as precise as the next method we're going to learn, but it can help with potentially getting a quick and dirty estimate of some costs. So for our example, to assume that we are the accountants for a hospital, right? And we pay a company of expert repairmen to maintain all of our equipment in this hospital. Now, some of the machines require that we service them every day and they get regular maintenance no matter how much they're used because they're such high precision machines. And I want you thinking of CAT scan machines, all sorts of science fiction, well, science realism machines that are used but need to be precisely maintained at all times, whereas others simply require service depending on how much they are used, right? Some fixed and some variable components to all of this. And depending on the machine, the repairman's expertise and fee will, of course, vary. And whatever parts need to be replaced will also vary. So the more you use things, the more parts will need to be replaced. And then again, there's just some things that we're going to be paying no matter how much we use them. So some fixed and variable components to all of it. And what you'll be given in both the homework problems and the exam problems and things that I want you to see, of course, in the real world, we would also be looking at prior months or prior periods data. And in this example, one concept that you need to be comfortable with is the concept of patient days, right, for the month. And the book does a good job of explaining this, that patient days are the number of nights that a hospital bed or a hospital room is occupied. And that would be basically what we are assuming or presuming is our activity level for this type of a business, right? So assume that we think our total monthly maintenance cost for our hospital is directly driven by the number of patient days, right? Or the number of times that a room is occupied by a patient. So the number of patient days for the month, and we think it is a mixed cost, part variable and part fixed, but we're not sure. And so we're going to use the scatter graph method to determine whether or not this is a true mixed cost that is also subject to prediction in some level. So let's assume that we're given the following data, and that's for the last 6 months. We know the number of patient days that we had, again, number of rooms that actually had a patient in them overnight, and the total maintenance cost incurred. Remember, that is a total. We think that is partly fixed and partly variable depending on patient days. So the way we'd use the scatter graph method can be shown in multiple steps. Step 1 is, of course, to plot the data points on a graph, and you will be graphing. I'll provide graph paper. If you have your own graph paper, feel free to use it or download any you like from the internet. So the first step is just to plot the data points on your graph, right? And of course, we're going to have activity running across the x-axis and cost, total maintenance cost, on the y-axis. So step 1 is to plot those data points on the graph. Step 2 is to draw a line through the data points with an equal number of points above and below the line. By the way, this line should be slightly lower. The graphic got a little messed up on my PowerPoint, so please excuse me there. It will correct itself in just a slide or two. But so you want to draw the line through the data points, right? And you want it to have that same sort of slope that we saw before with variable cost and mixed cost, right? Increasing with activity. Now, you want the same number of plots above the line as you get below. And by the way, if you can't draw a line that follows these rules, right, with the same number above, same number below, and it has this slope, well then what you're looking at is not a mixed cost with a variable component that can actually be predicted using this model that we are applying. But if you can, and if you do, what you want to do is have an equal number above as you have below. Step 3 is then merely looking and seeing where your line intersects with that y-axis, right? And that will help you determine the estimate of fixed costs. Wherever that line intersects the y-axis, that is your fixed cost, right? Everything below that line. So here looks to be about 10,000 estimate for our fixed cost. And that's great. That's the A in our equation, right? Where y is equal to A plus bx, right? Now we need to get that b and that x. And that's step 4. We want to come up with our variable cost now that we know our fixed cost. So remember, our fixed cost is 10,000. That's where this line intersects the y-axis. So what we want to do is choose one data point that is close to or on the line, and this one looks like it's real close, so we'll go ahead and take this one. And if we look back at the original data, we know that that's 800 patient days and $11,000 total dollars, right, for the month of January. So what we do is first take the total cost for that data point, which we know is $11,000, right? Now, that's the total mixed cost, $11,000, and we know our total fixed cost was $10,000. So what's the variable component? Yeah, real simple. Just subtract those two, right? If the total cost is $11,000 and we know the fixed cost is $10,000, well, then we know that the variable portion is $1,000. That's the variable. And we know what the activity was at this data point also, right? 800 patient days. So in order to determine what the variable cost is on a per unit basis, we simply take that $1,000 of variable cost and divide by the activity of 800 patient days from that one data point. Right? So again, we're taking the total cost, subtracting that fixed cost, which we had determined was 10,000, and that leaves us our total variable cost. But what we need is variable cost per unit. So we divide by the activity level, and we get a per unit variable cost. And that is, of course, our B in our equation. So we can plug that in very simply, and this is what our equation would look like. We know that our estimate of fixed cost is $10,000, and our variable cost per unit is $1.25. So we can plug in any number of patient days. If we're expecting a lot of patient days next month, we just plug in the number that we estimate, and we can know what our total maintenance cost bill is going to be. And it gives us a very powerful tool for estimating our costs. Keep in mind, of course, that the scatter graph method is a quick and dirty, or a rough estimate for determining fixed and variable component and a mixed cost situation. But a more precise method is, of course, the high-low method. For the high-low method, first we will determine the variable cost on a per unit level. And to do that, we divide the change in cost by the change in activity between the highest and lowest activity levels. And we'll talk about what that is in just a bit. But very simply, we take the high cost minus the low cost and divide that by the high activity level, subtracting the lowest activity level. Then, to come up with the total fixed cost, we simply take the total cost and subtract out our total variable cost, which we'll have determined previously. Show you what I mean in an example, and I think it'll make a lot more sense. So let's assume in this example we're still accountants for the hospital, but now we believe that our total maintenance cost is driven more closely related to maintenance hours, a different activity level and far more precise, we think, than patient days. And what I mean is that it's far more proportional, right? While patient days increase, our total maintenance cost might increase as well proportionally. With maintenance hours, there seems to be a far more closely tied relationship than with the patient days. So we're getting some better data in this example. And let's assume that the following data is given to us. That for the month of January, we had 625 hours of maintenance. That would be our activity. and a total maintenance cost of $7,950. By the way, what I mean here is the hours that we were paying our laborers, right? The total maintenance, all the maintenance people, if you combine their work, they work 625 hours in the month of January. Same thing goes for the month of February. Total combined maintenance laborers worked 500 hours during that month, and our total cost was $7,400. So what I said before, activity levels, is we're not looking at the highest and lowest maintenance cost necessarily. We're looking at the highest and lowest activity, which in this example is hours of maintenance. So what's the lowest, of course, and the highest? Well, the lowest is 500 hours and the 800 hours for this period that we're looking at, right? That's the highest number in there, and 500 is the lowest. And we take the cost that is associated with them. So we're not looking for the highest and lowest cost. We're looking for the highest and lowest activity and the costs that are associated with those. That's step one, just determining which those data points are. Step two is determining the variable cost per unit by dividing the change in cost, right? That's taking these two costs, subtracting the low from the high, and dividing by the change in activity. Once again, subtracting the low activity from the high activity. So let's go get those numbers in, right? So let's start with the bottom, the activity. We're taking the high activity of 800, subtracting out the low activity. And we're taking the costs that are associated with each of those. The cost that is associated with the high activity and the cost that is associated with the low activity, right? Just looking right over here. Do the math on those and we come up with $8 per hour, right? Subtract those out, you get 2,400. Subtract this out, we get 300 maintenance hours, which means $8 per hour is the variable cost per unit that we are paying. So B would be equal to $8 in our mixed cost equation. Step 3 is we're right back to that algebra, which I know you guys are all excited for, right? Well, once we know the variable cost per unit, which is that B, and the level of activity, which is X, and the total mixed cost, which is Y, we can then very easily determine the one unknown variable, A, right? Well, hang in there for just a second. Let's just assume that A in this equation is the one thing we don't know for now. Let's just use algebra, of course, to mix this thing up. And remember, with algebra, you want to isolate the unknown variable. So how do we do that? Well, very simply, if we are obviously adding the variable cost per unit and the level of activity on this side of the equation, if we move it over here, we would of course be subtracting it. And all of a sudden, A is isolated. And of course, to switch this around, we want the isolated variable on the other side. We just flip it, don't do anything else, just flip the order, and this is what it looks like. So now we're solving for the one unknown variable, A, right? And we already know these three because we just determined that B is $8, and we can just use either data point. We could take either the high data point and insert these numbers, or the low data point, and we will get the exact same amount. Let me show you what I mean. So we know that the B is $8, right? Variable cost per unit is $8 per hour. Let's start with the high level of activity, and we'll plug those numbers in first, right? Our total fixed cost is going to be equal to the total mixed cost minus the total variable cost, right? Makes sense. If this is a total mixed cost right here, we subtract out the variable portion, and what we're left with is the fixed. So let's do that. So we know that the total cost is $9,800 for this activity level. We already calculated the variable cost per unit as $8 per hour, and the activity level for this data point is 800 hours. So simply plug that in and multiply it out, right? This is what we come up to. $6,400 is the product here, and subtract it out, and the difference is $3,400. And that is our fixed cost. So we know that our fixed cost is $3,400, that's A, and our variable cost per unit is $8 per hour. So we've got our equation once again using the high-low method. And you might be saying, well, what if I would have used the low? Well, let's go ahead and use the low and see what that gets us. Hint, hint, it's going to get us the exact same thing, but let's do it anyways just to be certain. So, plugging in the low-level activity and the low-level total maintenance cost. Remember, let's go ahead and plug that in first using that equation as we rearranged it for algebra purposes. So, we know that our total fixed cost, which is what we're trying to solve for, is going to be equal to our total cost, that's fixed and variable, which in this data set is $7,400. Subtract out our total variable cost, which is, of course, $8 per hour multiplied by 500, the activity level. Plug those numbers in, multiply it out. The product there is, of course, $4,000. Subtract it out, and we get the same thing. Always good to test yourself by doing both the high and the low. So after solving that, of course, we can see that our cost equation for maintenance cost using that high-low method comes out to y equals $3,400 plus $8 times the activity level. And of course, we could use this to once again predict very precisely what our total maintenance cost would be in the future based on any level of activity. And predicting cost, of course, is one of the key components in determining profitability for a business. So this is a very rare and unique skill set that you're learning here that has real business applications. Hope you enjoyed, and I know that there was a lot of Justin Bieber in this chapter, but I know you guys are big fans, so I'm sure you'll love that too. We'll see you next time for Chapter 6.